So we want to differentiate this equation with two variables in it, and we can't just solve for y and be done with it. So this is called implicit differentiation. What we're going to have to do is take the derivative with respect to x of this, and then we pretend like y is a function of x, and we do the same thing. And really, this is just using the power rule and the chain rule. It's really the chain rule is what you're using here along with power rule. So let's do that. Let's do that right now. First of all, we're going to take the derivative of this with respect to x, and you're just going to get 4x cubed. And that's it, because it's a function of x. Well, now what if y itself was some function of x? Let's assume that y is some crazy function of x, like y is blah 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 with a bunch of x's in it, right? That's how I envision it. So what I would do is I would use the power rule to take the derivative of y squared first. So it would be 2y to the first, but then you'd have to multiply that. I don't even need to write the one there. Then you would multiply that by the derivative of the inside, which is dy dx. And then also I'm going to take the derivative of 2, which is just 0, because it's a constant. So now you can see dy dx. I have dy dx. I have only one dy dx here, and I can solve for dy dx, and that will give me dy dx. But it won't be just in terms of x. It'll be in terms of y and x. So to do that, this is just basic algebra. I'm subtracting 4x cubed, and now I'm dividing by 2y. So dy dx equals that. Now we're going to find d squared y dx, or the double derivative, I like to call that, just the double derivative of that. Alright, now to find the double derivative, it's a little bit trickier. I'm going to take the derivative, and I'm going to do once again, take the derivative with respect to x of that function. So again, I have two functions here, and it's a I'm going to have to use the quotient rule. So d squared y dx squared is going to be equal to low d high. The derivative of the high is negative 12x squared. So it's low d high minus high, which is negative 4. Be careful with your negative signs. Negative 4x cubed d low. And this is where you have to be careful. The derivative of low is going to be 2 times, when I do the chain rule, I just get 2, and then I have to take dy dx. So actually it's not that complicated. It's just 2 dy dx is what you're multiplying by, all over low squared, which is, let's just go ahead and distribute it in 4y squared. Now here's the trick, or one of the tricks, and I'll go ahead and do this since I'm running out of room. What we're going to want to do is take this right here and substitute dy dx in for dy dx, because if you ever have any dy dx's, go ahead and substitute that, what you got previously, because that's what it's equal to. It's a substitution problem, into there, and then you've got just a big old nasty problem, and you simplify it. So let me do that up here. So putting all of this up here, it's going to be negative 24 x squared y plus 8. Actually, gotta be careful. Oh, you know what? I'm an idiot. I should have just canceled this out at the very beginning. The 4 and the 2. It would have been a lot easier if I had just made that a 2. Yeah, that's pretty stupid. But it's okay. It's still going to work, but let's definitely do that for substituting it in, because it'll just make it easier. So it's going to be positive 8. It's going to actually be positive 16. All I'm going to have to do is simplify a little bit more at the end here. It's not a big deal. So that's going to be 16 x cubed over y. 16 x cubed over y. Oh, nope, because there's more x's here. So it's x to the 6th over y, not x cubed. That was x to the 6th. All over 4y squared. And then simplify this. Remember, Let's see, the best way to simplify this is probably to multiply it by y on the top and the bottom. And you get negative 24x squared y squared plus 16x to the 6th, whoops, 16x to the 6th all over 4y to the 3rd. And now, like I had mentioned to you before, we could simplify this a little bit more because I didn't in the first place. Cancel out a 4 from all of these, and you get 6 there, you get 4 there, and that's gone there. So your answer is negative 6x squared y squared plus 4x to the 6th all over y to the 3rd. And that's the double derivative.
Woohoo.